everyone. Today we go over lesson number 10, which is solving for slope-intercept form. Our learning targets will be able to rearrange an equation into slope-intercept form and identify, in fact, the slope and the y-intercept so that we can graph lines. What we're going to see today is standard form. Slope-intercept form is y equals mx plus b. That's what we're used to seeing our lines written in. But standard form is when they don't write it as y equals. Maybe there's something out in front of y, like an x, or maybe just a letter, or just a number, that is. So a, b, and c would be real numbers, but a and b both cannot be 0. That would give us an equation that is undefined, and that doesn't graph very well. So first one that we're going to do is actually all done for you. So we've maybe seen something like this before, but maybe not with two equations. We got 2y minus 6x equals 12, and we want to solve this for y. So I'll go through the steps for you, and then we'll talk about the properties that made this happen. So in the first step, they added 6x on both sides. Again, all in effort to get y by itself. And then instead of 12 plus 6x, wrote it as 6x plus 12. Divided by 2 on both sides, split that division up so that each piece was divided by 2, and ended in slope-intercept form, y equals 3x plus 6. Why don't we do that right now? We'll get ahead of ourselves. Who'd like to tell me the slope and the y-intercept based on what we did at the beginning of class? Evan? Perfect. Nope, what's the slope? It can't be the same number. 3, yeah, there you go. Cool. And why just say 3 over 1? Why not just 3? We want to, in fact, have that rise and a run. And sometimes we forget that any number can be written over 1. The reason why you can do all these things is because of the rules of math, the properties of math. So in the first one, adding 6x on both sides, who remembers what property that one is? Rachel? You got it. We're going to do it to everything. Property of equality. Very nice. And then the little bit of a rearrangement. Small thing here, 12 plus 6x to 6x plus 12. John, that's when we group things together. So the other one? You're on the right track. Commutative, yes. We are commuting. We are going back and forth. So our commutative property. Then divided by 2 on both sides. Really multiplying by half. But Gary? Doing it to both sides of the equal sign. Nope, saw it with the first one. But all those mistakes are going to help us learn. So that's good. Property of equality, again, this time with multiplication. And then the last thing, they split it into 2 pieces. So when you divide by 2, everything gets divided by 2. This is a form of the distributive property. Okay, so you've got an example already down, completely right, to kind of follow as we go over the 3 that you see at the bottom. And that's it. These 3, and we walk to the practice. So I will do the first one, we will do the middle one, and then you will do the last one. So that same I do, we do, you do mentality. So the first one, without any assistance at all, 3y minus 3x equals 15. If you want to think of this as a left and a right side, not a bad idea. But first step would be to add 3x. Move it from the y side to the non-y side. All this does is cancel it out, makes a 0 pair, and we are left with 3y equaling, and here's the tricky part. Remember, unlike terms don't like being put together, so don't try it. And 15 plus 3x can be written as 3x plus 15. So I'm using the commutative property to write that variable first. That's more of the order we would want to put it in. Finally, let's divide by 3. Now everything gets divided by 3, so why not just break it up into little fractions right now instead of one big one? Dividing by 3 makes 1 here, so in fact, y is by itself. Simplify whenever you can. 3 divided by 3 is in fact 1x. You may want to leave it as a fraction so you have a slope, a rise and a run for that matter. And then adding 15 divided by 3, we'd end with 5. Always make sure you're identifying the slope and the y-intercept. So we got that equation to y equals 1x plus 5. Remember that whenever you graph, you want to start at the y-intercept. Start where this number doesn't have any variable attached, and the y-axis is the one that goes up and down. So right here at 5. Your slope is the number next to x. Want to make it a rise over a 1? You can always divide something by 1 and not change the value. So up 1 over 1, up 1 over 1, up 1 over 1. Go forever that way, or down 1 and right 1, down 1 and right 1. As soon as you have points on either side of the y-intercept, connect it, extend it, put arrows on it, and then don't forget, we're going to need to label these because we'll start putting more than one line on a graph, and you have just graphed the equation. Now remember, it didn't start like that. This equation started as 3y minus 3x equal 15, but we were able to solve it into slope-intercept form. So, up in getting y by itself. Evan. Yeah, that's a good place to start. Subtract 5x. Makes 0 out of all that. So your 2y equals, and again, don't add or subtract things that aren't alike. Don't put this together for negative 13x. In fact, rewrite this simply as negative 5x minus 8. Once we get it here, we got one thing left. What's that one thing, Rachel? Divide by 2, and everything gets divided by 2. And so 2 divided by 2 makes 1, so y is by itself. And here we get it to a situation where 2 doesn't go very nicely into 5. That's not something that we want to write as a decimal, so let's just leave it as negative 5x over 2. And we're actually happy about that. Why are we happy about that? Why is that totally fine? One less step for when we do what? The whole point of this is to get it, so Gary, what's the reason for that board on your desk, John? To get the slope so that we can graph, right? So that we can end up just doing the rise and the run. 8 divided by 2 does work out nicely. That is negative 4. With the graph boards you have in front of you, would you please graph that line on your board? So who'd like to get us started with letter C? First thing you'd want to do to get slope-intercept form. Gary. You could, all right? I'm not saying you can't, but remember the goal is to get y by itself. And I typically would rather have y on the left side. So doing that would move it to the right, and that would just create more steps. Yeah, so subtracting x and maybe putting a 1 there will help you realize what to do, because it's the same first step here and it's the same first step there. You move the number and the variable by doing the opposite. Now again, do it to both sides. Use the property of equality. You got 0 here, negative 3y equaling. I got a question for Ty in the back. Can we add or subtract 6 minus 1x? Is that possible? That's like eating an ice cream cone in the rain, Tyler. Ty, that's just not going to work. Okay? What's that? No, yeah. So don't put this together as 5x. It's simply negative 1x plus 6. And you can put it in any order, but putting it in that order would actually be better. Riley, what would we do next here? Get y by itself. Yeah, so the steps are always kind of the same. I divided by 2 there, divided by 3. This time I am going to divide by a negative and make sure that everything gets divided by that negative 3. What we did is got y by itself. It's closer and closer to slope-intercept form. Whenever you can simplify, do. Like a negative divided by a negative is really a positive. But if you wanted to keep it 2 negatives, that's fine. Just don't make it 1 negative. That would be bad. And then positive divided by negative would in fact be -2. Okay, and there you have it. All set. Go ahead and try the practice assignment and let me know if you have any questions.